Conditional random fields. Introduction. Conditional random fields, CRFs, are a class of statistical modeling methods often applied in pattern recognition and machine learning and used for structured prediction. Whereas a classifier predicts a label for a single sample without considering neighboring samples, a CRF can take context into account. To do so, the predictions are modeled as a graphical model, which represents the presence of dependencies between the predictions. What kind of graph is used depends on the application. Examples where CRFs are used are labeling or parsing of sequential data for natural language processing or biological sequences, 1. Part of speech tagging, shallow parsing, 2. Named entity recognition, 3. Gene finding, peptide critical functional region finding, 4. And object recognition, 5. And image segmentation in computer vision. Characteristic features. Conditional random fields, CRFs, possess several characteristic features that distinguish them from other probabilistic models. 1. Conditional modeling. 2. Graphical representation. 3. Label dependencies. 4. Features integration. 5. Structured learning. 6. Inference algorithms. 7. Label transitions. 8. Semi-supervised learning. 9. Structured output. 10. Interpretable dependencies. 11. Regularization. 12. Combining features. Mathematical overview of CRF. As a summary, we use conditional random fields by first defining the feature functions needed, initializing the weights to random values, and then applying gradient descent iteratively until the parameter values, in this case, lambda, converge. We can see that CRFs are similar to logistic regression, since they use the conditional probability distribution, but we extend the algorithm by applying feature functions as our sequential inputs. How CRFs differ from hidden Markov models? Hidden Markov models are generative, and give output by modeling the joint probability distribution. On the other hand, conditional random fields are discriminative, and model the conditional probability distribution. CRFs don't rely on the independence assumption that the labels are independent of each other, and avoid label bias. One way to look at it is that hidden Markov models are a very specific case of conditional random fields, with constant transition probabilities used instead. HMMs are based on naive Bayes, which we say can be derived from logistic regression, from which CRFs are derived. Advantages. Conditional random fields, CRFs, offer several advantages in various fields, including natural language processing, computer vision, and bioinformatics. 1. Structured output. 2. Global dependencies. 3. Feature flexibility. 4. Explicit modeling. 5. Inference. 6. Structured learning. 7. Semi-supervised learning. 8. Multitask learning. 9. Effective post-processing. 10. Interpretability. Disadvantage. While conditional random fields, CRFs, offer numerous advantages, they also come with certain limitations and disadvantages. 1. Complexity. 2. Feature engineering. 3. Scalability. 4. Label bias. 5. Global dependencies. 6. Limited expressiveness. 7. Lack of flexibility in output. 8. Parameter tuning. 9. Interpretability challenges. 10. Data annotation. Applications. Given their ability to model sequential data, CRFs are often used in natural language processing, and have many applications in that area. One such application we discussed is parts of speech tagging. Parts of speech of a sentence rely on previous words, and by using feature functions that take advantage of this, we can use CRFs to learn how to distinguish which words of a sentence correspond to which POS. Another similar application is named entity recognition, or extracting proper nouns from sentences. Conditional random fields can be used to predict any sequence in which multiple variables depend on each other. Other applications include parts recognition in images and gene prediction. Thank *U.